Yeah. Get the Hawaii job, right? Carl graduated with a BS in geography from Arizona State University in 2013 and has completed the AWS, which is the Amazon Web Services Technical, Professional Business, Professional and Total Cost of Ownership, Cloud Economic Accreditation. That's a mouthful. They need a longer acronym for that one. He's working towards the AWS Solutions Architect certification. He's interested in leveraging AWS Cloud Computing Solutions, Azure JavaScript API, ArcGIS, Web App Builder, and mobile GIS applications to meet the needs of clients. So with that, we'll turn it over to Carl, and he can introduce his co-presenter.
Welcome. Thank you. And I'm here with James Cooper, who I work with, and I'll let him introduce himself.
All right, how's everybody doing?
Good. All right.
I'm gonna say you fool. I'm gonna say I have enough chicken. It's not sitting well right now. We're gonna try to make this smooth and fit and quick for you. Yeah, my name is James Cooper. Work for EnerGIS Consulting based out of San Diego. It's a certified small business enterprise. Started back in 2009. As you see, we specialize in streetlight conversions. I actually graduated from Shippensburg University, well, which isn't too far from here. I don't think anybody here is from. Oh, how you doing? You know, I'm a fan of Cal. I'm a fan of all my PCS schools, but I got to be proud right now.
I understand.
But yeah, I guess we're going to get going, and we're going to talk about utilizing mobile GIS for streetlight audits and conversions. So the question we're going to start off with is, why do a municipal streetlight conversion? To boil it down, it cuts municipal electrical bills in half. It saves a lot on maintenance. You can implement central control systems. Take, for example, we've worked with the city of San Diego, which is the 8th largest city population-wise in the country. And dealing with the drought right now, they're money hungry, to try and find new resources and things, and money could definitely be going to different sectors for the city. So we help them convert a lot of streetlights downtown and in the surrounding areas of San Diego. And for this project, it's an $18 million project. It cut the electrical bill for streetlights annually from $4.3 million to $2 million. And that's just on 2 jobs. So converting streetlights, from what they traditionally are HVS, which is high pressure sodium, mercury vapor, metal halide, they're really outdated. So converting them to LED, which is a movement that's growing across cities now, is definitely a great tool. Speaking about LED lights, they last for about at least 15 years compared to the HVS lights and mercury vapor lights, which typically need maintenance every 3 to 5 years. And also with implementing streetlight conversions, like as I said before, you can implement central management control systems. Take for example, with the city of San Diego, because they updated their streetlights, they're able to have this system set up where they have their streetlights on full blast up until 10 p.m. And then after 10 p.m. they lower to 80%. And then by 2 a.m. they're down to 60%. This saves a lot of money on energy. There are lots of other things that could be done by converting streetlights, and this can turn the conversion process from streetlights from a liability to a profit exit. So a little bit about Ivari. Ivari is a leader when it comes to implementing GIS technology solutions for streetlight conversions and retrofit projects. Streetlights are woven throughout a community in a geographical nature, containing large amounts of data. Because of that, GIS is a great tool to help streamline and facilitate clear communication between municipalities and contractors alike. What we do as a business, we develop interactive web and mobile applications for our clients that update in real time as data changes. This provides a complete transparency into the progress of a project. The system that we implement and set up provides the city with a comprehensive GIS database of all of their streetlights. And it can contain data such as location, voltage, wattage, data installation, as well as a link into contractors' data. A lot of times we've noticed that cities hire contractors to do the installation and conversion of their streetlights, and they're unaware of how many streetlights they have in the field, or they're unaware of how many streetlights they've already converted to LED. So with this updatable system, we actually give them a nice spreadsheet and that's updatable, so they know what's in the field. And with the interactive and web and mobile applications, this allows data editing to no longer be confined to just the office. But it can also be utilized on site by the people who understand the project best, whether that's installers or audits. Our business typically deals with audits, but there are some situations where we set up a system and installers are the ones who do the audits. In conclusion, this type of system enhances project management tactics by bringing value to making key decisions for obstacles the contractors may face. There are plenty of situations where a contractor's in the field and they're trying to install lights, but they may be hindered by trees, or there may be fixtures that they're not aware about. So when it comes to ordering new fixtures, new street lights, they don't want to order too much if there's already LED lights in certain areas that they're not aware of. Because in the past, they converted LED lights, they converted street lights on a single light basis, which isn't the best way to do it, because you're not really knowing what's in the field and you're not really knowing exactly how much energy you're using. You know, an old HPS light, an old mercury vapor and metal halide light uses 400 watts of energy compared to an LED light which uses 25 watts. And that's just for one street light.
So our system, we use Amazon Web Services and ArcGIS for server. And the Amazon Web Services, we have a SQL Server instance running Windows 2012 with ArcGIS for server on it. And it's SQL Server Express. And we keep this on a M3 extra large box, which has 4 vCPUs, 15 gigs of RAM, and solid state drive storage. So this is we've started off with smaller servers, and as we've gotten bigger projects, we've started scaling it up to a bigger server, and the end goal is to eventually have multiple servers balancing the load so that we can handle like a large project. Usually we have about 4 to 6 editors in the field at one time, and sometimes there are multiple projects going at once. And yeah, so AWS, it really allows us to scale and cost savings from not having to own our own server. We're just renting the server, and we pay for what we use. If we're a small business, we wouldn't want to pay for a whole server room or have to worry about cooling or rent from a co-location place. It makes a lot of sense for us to be on the cloud. And then we also have control over security. Our servers are launched into a VPC, which is a virtual private cloud. So it's a section of the Amazon cloud that is ours. So we can configure the networking to only allow certain IPs to view the services, and it really lets us lock down the security with our work. And it's also easy to try new things and develop. I mean, we can just spin up a new box and try 10.3. We currently use 10.2, but we could launch a new instance with 10.3 and just really try new things. So it allows us a lot of flexibility to develop. With ArcGIS Server, we use SDE feature classes that are published as services. So it's real time. The contractor can literally be like sitting in his office and refresh the map and see new lights that we audited, or if there's a conversion going on, he can see like someone converted a light, but there might be a mistake, so he can check that right away in real time and give the guy a call and tell him he messed up. It also gives us a little more flexibility using ArcGIS for server than using ArcGIS online. We want to have full control over all of our services, and the event we still use our GIS online for like our web maps. We consume our services in the web maps, but the eventual goal is to just have a JavaScript map that is consuming the services, and we control the authentication and everything, and we kind of leave ArcGIS Online out of it, because dealing with like portal and stuff like that, you know, we have a limited number of users, so it can kind of hamstring us or make us have to pay a little extra. And then we also have attachments and editor tracking with the SDB database, so we know when the points are created, we know when they're edited. If a guy's out in the field and he sees something he doesn't know what it is, he can take a picture of it, and we actually symbolize the data so that someone who knows about the streetlights can easily pick out that point that has an attachment and look at it and see what the deal with it is. So each project really presents its own challenges. I mean, when you're getting energy company data, we've kind of seen it all. Like, sometimes we get XY coordinates, that's when we're lucky. Usually it's some jumbled address, and we have to figure out where this point is supposed to be when we're geocoding. But we go through all that, and we get the points on the map, and then we get guys out in the field to confirm what's out there, confirm where the energy bill's wrong, and then give the client good data. And then using ArcMap, we have a series of models that run every night. We have a batch file, so it's going to run through a whole nightly process every night. So we calculate the status history. That'll make note of any changes. If they're converting lights, it calculates the date that the light was converted. If we're auditing, it'll give the audit date. We also calculate a link to Google Maps. So that basically goes into the spreadsheet, and the contractor can just click it, and it'll take you straight to Street View, so you can look at the light and see if there's some issue, you can just see what's going on. And we also, in certain cases, we've had to calculate like a municipality. So we worked in Riverside County back in California, across 17 cities. So we needed to make sure we were getting bills from each city, and we needed to make sure that the lights on their bill were actually in their city. So we would run an intersect with a city boundary nightly, and it would tell us what city the light's actually in. And I'm sure there will be a lot of disputes that come out of that between the cities, but it's good to make sure that, you know, everyone's lights are in the right place. And we also did the same with the Cape, where we actually had 23 municipalities and Martha's Vineyard. So that was very useful for us to be able to use that. We also will export to a spreadsheet, a 3-tab spreadsheet. So we want to tell the contractor which lights match the bill, which lights are on the bill only, and which lights are on the field but not in the bill. And usually we find about 5 to 10% error on most projects with the energy company's data of lights that are either missing or the city's getting billed for a light that doesn't exist. And then we also use keywords. So it'll run a model that searches for certain keywords. So if we find a mercury vapor light out in the field, the contractor wants to know where those are, because you have to be more careful with mercury lights. So we would have a keyword written in, and then the model would calculate the type of light based on that. So front end, we use a mobile app. So we use it on iPad. We've kind of messed around with different apps. This is just the ArcGIS app that you can download in the App Store for free. We've tried it on Android and phones also, but we like the iPad a little more. The Android is a little bit clunkier, but it's getting better. And then in the field, we used a Verizon wireless card, so we're always connected. We've never really had a situation where we haven't been able to get phone service now, so it's gotten a lot better over the years. So we're always connected. we haven't really had to do disconnected editing, but that's something we would do if we had to. When we were out in Hawaii, there were some remote places where the signal was pretty bad, but for the most part, we get a good 4G signal everywhere. And then the read-only website, so this is using the Web App Builder Developer Edition. So right now I just kind of am using it out of the box and making little customizations to the code. I've been working on learning JavaScript over the last half year, so I'd really like to get to the point where I write the whole app, but right now it's all out of the box with the Web App Builder. Before we use the Flex Viewer, I don't know if anyone's familiar with Flex Viewer, but the problem with that was it didn't work on mobile devices for our apps. So this JavaScript, it's agnostic to whatever browser, and it works pretty much on any device. So it's really nice. You can just pull up the map on your phone, take a look at something, and we actually have a demo. So James is going to create a point on the iPad, and then we are going to see it on this web map. So there's different tools you can add. So there's a ruler. So if the contractor wants to see, like, how far apart are these streetlights, they can measure distance. And then there's also bookmarks. So if you find something interesting and you want to bookmark it and come back to it, you can save it as a bookmark. And then there's also an edit tool. We still need to work through the edit tool on this. It's not quite as user-friendly as on the iPad app. All right,
So I added a point, like, showing like what an installer or an auditor would do in the field. For this point, I just added a 250-watt high-pressure sodium Cobra head. And you can add attachments to it, such as pictures, and I voluntarily done that. So being a manager or contract management or municipality management team in the field, they can refresh the screen, and it pops up on their screen. So say if there's a problem, they see it immediately.
So here's the point you created. 250-watt high-pressure sodium Cobra head. And then attachments, there's a photo, so you just click that. And then there's all your photos.
I'm sorry, I had to put you in place.
It's not texting.
Okay, and then the other service we give our clients is an FTP site that has daily spreadsheets that they can download. So this is a good way for them to track the data, and most of the guys I work with, they'll check it every morning and kind of see how their team is doing. So it's just you just click the link and it starts downloading the spreadsheet. So it's a good tool for them.
So yeah, one project we worked on, as he told you, we work a lot in the Northeast region from Connecticut to Massachusetts to New York, and always going to the west of Honolulu. But a recent project we did was in Fall River, Massachusetts. We worked hand in hand with Amoresco in order to audit in excess of like 6,500 streetlights for the city of Fall River. And as we said before, each project has its own system set up independently of other projects in order to meet the needs of the client. Like take, for example, a client wants to gather information in fields such as pole height, or, there's some clients who want to gather every individual streetlight and they want to connect it to an address rather than an XY coordinate. And we can set that up, and then we run the model every night and it comes up in the FTP site. So the management team sees it immediately and things go smooth. For this project, we were just tasked with geocoding instar light data in ArcMap, and we kind of did this just by locating the closest intersection for all the streetlights, because they really had no clue exactly where the streetlights were. They just knew they were near this given area. And they actually had some route numbers and pole numbers, which are good, but when you're always updating streetlights on a one-by-one basis, things don't match up. And that's kind of why they kind of hired us to help streamline this process of auditing. So, we geocoded it based by close intersections. We also use a disperse tool to spread points out along a single road. And then we also use a walking analysis. And this model just helped create polygons in the field that were more advantageous to walk and spread our teams out and walk down rather than drive. Because you deal with a lot of cities and performing these street audits. You're dealing with a lot of traffic and congestion, and that's something you don't want to have to hire policemen to block off certain roads. So it saves the company and it saves the contractors a lot of money. But yeah, we performed this walking analysis and this better positioned our work crews and it made the audit process go by within a matter of weeks instead of months.
And I already talked about the Cape a little bit. Just wanted to add a couple things. So the whole entire Cape, they actually finished converting their lights around January, I believe. So all those municipalities, they're saving 70% on energy and $800,000 a year on the electric bill and maintenance sales. So it's really going well for them, and they're really happy with it. And we were actually based in Brewster, Massachusetts, which is kind of central. So we were an hour away from Provincetown in the northeast and Falmouth in the southwest. But we would have to drive out an hour every day to kind of get out there. And this job was with Siemens in the Cape Light Compact. And this picture here is a before and after. It kind of shows how the LED lights have changed the way the streets look out there. It's with the high pressure sodium orange light. There's not much detail, and when you get that LED in there, it's really a lot more clear. And this is just the energy savings spreadsheet by town. The Hawaii Department of Transportation. So we actually worked on 4 different islands: Oahu, Maui, Lanai, and Molokai. And that project was challenging because we had 6 weeks to do 17,000 streetlights. So we had a team of 8 people just running around, driving up the freeways. Sometimes we had to have a traffic control with 3 police officers and an attenuator truck behind us on the busy freeways. We were inside the tunnels. The Tetsu Hirano tunnel is actually a mile long, and there's 500 lights on each side going east and west. So we were just driving through there, looking up the streetlights.
So to kind of end this off, we've been able to do this type of work on these type of projects because they have data acquisition requirements and a geographical nature, and that's basically what GIS is. We found real value across all the stakeholders we've been involved with. Converting streetlights is a growing niche, something I never knew about graduating just a year ago. But there's real value in this, and GIS is a great tool for it. We also believe, the public may be interested in figuring out when a light near their home or work is going to be converted. And that's up to the contractor, the municipality, to give the public read-only access, which is the JavaScript web app, where they can oversee progress going. And I feel like a tool like that helps gain trust between the public and the government, because they're spending multi-million dollars on these type of projects, and the public they want to know where their money's going. They're dealing with other problems. So they want to know if it's really going to bring value for them or if it's not. And a tool like this, giving them access to it, visually, can gain more trust and help the city get more done. This type of technology and this type of system can be applied to plenty other projects as we're currently getting involved in, whether that's asphalt overlay. I know many cities nowadays are tired of the potholes. Everybody owns a car nowadays. This type of system can definitely help the city replace certain roads that they're not even aware need replacement. And I notice a lot of times, even back in my city, I grew up in Baltimore, they repave a road every 5 years, but there's some roads in some areas that never get touched. So this type of system can help with asphalt overlay, transportation, energy audits of buildings, and other infrastructure projects. And we'll end it off with that.
I just wanted to point out that this is in 1910, and this is a couple years ago. And before we worked with these contractors, they would just go around with a spreadsheet and highlight lights after they were converted. So we think that they're using different technology. I think they should embrace GIS, and I think it can be a really valuable tool for a lot of people doing this kind of work. So, all right, that's it.
We have a few minutes for a couple of quick questions. Do you have any questions?
Was it actually just the bulb that was being replaced, or was it the entire fixture?
Sometimes they do a retrofit where they will change the bulb out, but more often than not now, they're taking the whole fixture out and putting a new LED fixture in there. There have been problems with some cities that have actually just done a retrofit and changed the bulb out, and I think doing the full conversion is more effective.
Question. Are you guys grabbing the location using the collector app as well?
Yeah, we do heads-up digitizing in the field. So our guys, they have a high-accuracy GPS that's connected with Bluetooth, and they're looking at the aerial photo and placing the point based on what they're seeing on the photo. So sometimes you can see the shadow, or you can look at houses.
So for that tunnel project, did you have like a Wi-Fi extender, or did you have to collect the data offline?
The tunnel we actually did have to do offline. We went in there with some notepads, and you're basically just only lights. So you're writing down the patterns and how many lights are in each set of lights. Because at the beginning of the tunnel, they really blast you with the light and have a lot of them. Then as you get further in, it becomes more spread out. So we had to do that disconnected.
Any imagery, right?
That's kind of the next thing we're looking at with like RP8 compliance, and we're trying to kind of implement that with the city of San Diego and be able to run an analysis for them to show where like they need more light based on the reflectivity and that kind of stuff.
That was my question.
Thanks, guys.